Our planet's deep rhythms reveal a world of incredible, unhurried change. Plate tectonics reminds us of Earth's incredibly slow, steady, and ancient geological processes unfolding over millions of years. Imagine, if you will, the deepest breath our Earth takes, stretching not over seconds or minutes, but over vast epochs of time, each exhalation and inhalation reshaping continents. It's a testament to patience, this grand, deliberate waltz of land and ocean, a process so profoundly slow that it truly defies our everyday understanding of movement. This isn't a sudden cataclysm, but a quiet, persistent evolution, shaping mountains and valleys with an almost tender hand, leaving behind a legacy readable only in the planet's vast geological record. Each ripple in a mountain range, every deep ocean trench whispers of these ancient, steady forces, reminding us that true change often happens with an imperceptible grace, a soothing, continuous reshaping that defines our world over an unimaginably long stretch of existence, inviting us to slow down our own sense of time. The continents drift at roughly the same rate as human fingernails grow, a gentle and imperceptible journey. This comparison offers a truly serene perspective on the planet's dynamic surface. Picture your own fingernail lengthening so gradually that you cannot perceive its growth moment by moment. Yet over weeks and months, the change becomes undeniable. In much the same way, the great land masses of Earth are engaged in a perpetual, silent journey, inching across the globe with an unhurried elegance. This remarkable slowness means that over a human lifetime, the drift is negligible, a mere whisper of movement, making the continents feel utterly fixed beneath our feet. Yet, beneath this illusion of permanence, the vast lithospheric plates continue their gentle, ceaseless migration, a reminder that the most profound changes often occur with the least fanfare, silently, patiently, for millions upon millions of years, an eternal, quiet pilgrimage of land. Earth's outer shell is made of massive, interlocking plates that float serenely on the semi-fluid mantle. Envision a giant cosmic jigsaw puzzle where each piece is an entire continent or ocean floor, drifting almost effortlessly on a layer of rock that behaves like very thick, warm caramel over geological timescales. This isn't a violent smashing or grinding, but a slow, majestic glide, a deep planetary sigh. The semi-fluid nature of the mantle is key here, providing a yielding, viscous surface that allows for smooth, continuous motion, preventing the rigid plates from locking up entirely. This floating mechanism ensures that the planet's surface is never truly static, always in motion, but with a gentle, flowing grace that belies the immense power involved, maintaining a state of serene, dynamic equilibrium for billions of years. It's a comforting thought, this planet gently rearranging itself. The constant, gradual movement of these plates helps maintain Earth's delicate internal heat balance over eons. Deep within our world, immense heat is generated by radioactive decay, and this energy needs a way to escape. Plate tectonics acts as the planet's slow, grand cooling system. As new crust is created at mid-ocean ridges and old crust is recycled at subduction zones, it facilitates the convection of the mantle, carrying heat from the interior to the surface in a continuous, unhurried cycle. Without this elegant mechanism, Earth's interior might overheat, leading to very different, perhaps less hospitable conditions. So these seemingly slow, gentle movements are actually vital to regulating the planet's thermal heartbeat, ensuring a steady, long-term stability that has allowed life to flourish, a testament to Earth's profound self-regulation. Subduction zones gracefully recycle old oceanic crust back into the mantle, a perpetual renewal system for our planet. Picture a grand cosmic conveyor belt, where one massive plate slowly, almost reluctantly, dives beneath another, melting back into the Earth's fiery interior. This process is not a destructive end, but a vital part of Earth's ceaseless regeneration. The oceanic crust, having served its purpose on the surface, absorbing ocean waters and carrying sediments, returns to the deep, enriching the mantle and priming it for future volcanic activity. This isn't a violent smashing or grinding, but a slow, majestic glide, a deep planetary sigh. The semi-fluid nature of the mantle is key here, providing a yielding, viscous surface that allows for smooth, continuous motion, preventing the rigid plates from locking up entirely. This floating mechanism ensures that the planet's surface is never truly static, always in motion, but with a gentle, flowing grace that belies the immense power involved, maintaining a state of serene, dynamic equilibrium for billions of years. It's a comforting thought, this planet gently rearranging itself. The constant, gradual movement of these plates helps maintain Earth's delicate internal heat balance over eons. Deep within our world, immense heat is generated by radioactive decay, and this energy needs a way to escape. Plate tectonics acts as the planet's slow, grand cooling system. As new crust is created at mid-ocean ridges and old crust is recycled at subduction zones, it facilitates the convection of the mantle, carrying heat from the interior to the surface in a continuous, unhurried cycle. Without this elegant mechanism, Earth's interior might overheat, leading to very different, perhaps less hospitable conditions. So these seemingly slow, gentle movements are actually vital to regulating the planet's thermal heartbeat, ensuring a steady, long-term stability that has allowed life to flourish, a testament to Earth's profound self-regulation. Subduction zones gracefully recycle old oceanic crust back into the mantle, a perpetual renewal system for our planet. Picture a grand cosmic conveyor belt, where one massive plate slowly, almost reluctantly, dives beneath another, melting back into the Earth's fiery interior. This process is not a destructive end, but a vital part of Earth's ceaseless regeneration. The oceanic crust, having served its purpose on the surface, absorbing ocean waters and carrying sediments, returns to the deep, enriching the mantle and priming it for future volcanic activity.
It's a testament to nature's perfect efficiency, a continuous cycle of birth, life, and gentle reabsorption, ensuring that the planet's surface is always fresh, always renewed, never static, a deep, quiet promise of geological continuity and eternal rebirth. Mid-ocean ridges quietly generate new seafloor, a continuous, slow creation process deep beneath the waves. Imagine a colossal, underwater mountain range stretching for tens of thousands of miles, where molten rock from the mantle gently wells up, solidifies, and pushes the existing ocean floor apart, centimeter by silent centimeter. This is where new oceanic crust is born, far from human eyes, in the perpetual twilight of the deep sea. It's a process of quiet, steady expansion, slowly adding fresh material to our planet's skin, like a slow-motion growth ring. This continuous creation ensures that Earth's surface is always expanding in some areas, balanced by the recycling occurring elsewhere, a testament to the planet's dynamic equilibrium, a tranquil engine of geological expansion that keeps the oceans alive and vibrant with new seabed. The Himalayas, though majestic, are rising at a tranquil pace of about 1 centimeter per year, a slow-motion marvel. These towering peaks, the highest on Earth, are not static monuments, but living, growing giants, pushing ever so slightly higher with each passing year. This gentle upward heave is the result of the Indian plate continuously colliding with the Eurasian plate, a testament to the colossal yet unhurried forces at play beneath our feet. While the sheer scale of the mountains might suggest violent upheaval, their growth is a study in patience, a centimeter at a time, accumulating over millions of years to create the breathtaking vistas we see today. It reminds us that even the most dramatic landscapes are sculpted by time, not speed, a slow, gentle uplift that defines a mountain range over geological eternity. Alfred Wegener's theory of continental drift, proposed in 1912, brought a calming understanding to Earth's restless surface. Before Wegener, the idea of fixed continents was widely accepted, leaving many geological mysteries unexplained. His revolutionary concept, though initially met with skepticism, suggested that continents were not anchored in place, but had moved across the globe over vast timescales, like silent ships on a vast ocean. This simple, elegant idea, supported by evidence like matching fossil records and rock types across oceans, began to offer a coherent, soothing explanation for many of Earth's seemingly random features. It wasn't until decades later that the full mechanism of plate tectonics would be understood, but Wegener's initial insight laid the tranquil foundation for our modern, calming understanding of a dynamic, ever-changing Earth. Deep-sea vents, formed by plate activity, foster unique ecosystems in the perpetual calm of the ocean floor. Far from the sunlit surface, where most life relies on photosynthesis, these extraordinary havens thrive in total darkness, drawing energy from chemicals released by Earth's interior. Imagine plumes of superheated, mineral-rich water spewing from cracks in the seafloor, providing the foundation for incredible communities of tube worms, clams, and unique microorganisms. These vents are directly linked to the spreading of tectonic plates, where new crust is forming and magma is close to the surface. Their existence is a gentle reminder of life's adaptivity and Earth's hidden geothermal energy, creating oases of vibrant life in the deep, quiet abyss, a testament to the unexpected beauty that arises from slow geological processes. The gentle spreading of the Atlantic Ocean widens by a few centimeters each year, a testament to Earth's ongoing quiet evolution. Take a moment to consider the vast expanse of the Atlantic, stretching between Europe, Africa, and the Americas. This immense body of water isn't a static feature, but a slowly expanding canvas, growing wider with each passing moment, albeit imperceptibly to our senses. The Mid-Atlantic Ridge, a colossal underwater mountain range, is the engine of this expansion, where new oceanic crust is continuously generated. This gradual process means that future generations, millions of years from now, will find these continents even further apart, a slow, patient migration driven by Earth's deep internal forces.
It's a comforting thought, this slow, deliberate unfolding of geography, a peaceful, continuous reshaping of our watery world. Plate tectonics provides a comforting framework for understanding Earth's long-term stability and geological cycles. Far from being a chaotic and unpredictable planet, Earth, through the lens of plate tectonics, reveals itself as a marvel of self-regulation and predictable patterns over immense timescales. The cycles of subduction, spreading, mountain building, and continental drift all contribute to a grand planetary rhythm that maintains the conditions necessary for life. It offers a sense of order to what might otherwise appear as random geological events, showing how volcanoes, earthquakes, and mountain ranges are all interconnected parts of a vast, elegant system. This holistic understanding allows us to appreciate Earth as a living, breathing entity with its own ancient, stable rhythms, bringing a profound peace to our contemplation of its deep history. The Earth's magnetic field, generated by its core, is influenced by plate movements, offering protection over vast timescales. This invisible shield, crucial for deflecting harmful solar radiation and preserving our atmosphere, isn't entirely separate from the surface dynamics. While the magnetic field itself originates in the liquid outer core, the slow drift of continents and the formation of new crust at mid-ocean ridges leave a magnetic signature in rocks, recording the field's past orientations. This paleomagnetic record provides vital clues about the Earth's ancient magnetic field and its occasional reversals, reinforcing the interconnectedness of Earth's deep interior with its surface processes. It's a subtle but profound link, highlighting how the patient movements of plates contribute to our long-term planetary well-being, a gentle, unseen guardian of life. Ancient supercontinents like Pangaea formed and broke apart with a slow, majestic rhythm over hundreds of millions of years. Imagine, if you can, a time when nearly all the landmasses of Earth were united in one colossal continent, a single, vast expanse surrounded by a global ocean. This wasn't a static state, but a phase in Earth's grand continental ballet. Pangaea itself was just one of several supercontinents that have assembled and fragmented over billions of years, driven by the ceaseless flow of the mantle beneath. Each breakup and reassembly occurred with an unhurried, epic slowness, painting and repainting the face of the planet across unimaginable stretches of time. These cycles of supercontinental formation and dissolution are a testament to Earth's eternal rhythm, a slow, majestic dance that has shaped the distribution of life and oceans throughout our planet's deep history. The tectonic plates move smoothly, mostly without friction, allowing for the slow, continuous reshape of continents. It might seem counterintuitive given the immense mass and rigidity of these plates, but their movement isn't generally a jarring, grinding affair. Instead, the boundary layers often contain ductile, warm rock that allows for a surprising degree of fluidity over long periods. Think of a very thick, slow-moving syrup rather than two sandpaper blocks rubbing together. This smooth, low-friction motion is essential for the graceful, continuous rearrangement of Earth's surface, preventing constant, violent seismic events across all plate boundaries. It allows the continents to glide rather than crash, ensuring a more stable, albeit dynamic, geological environment. A quiet, flowing ballet of landmasses across the planetary stage. Volcanoes, though powerful, are a natural release valve for Earth's internal pressure, maintaining equilibrium. While often associated with dramatic eruptions, volcanoes play a crucial calming role in the planet's long-term health. They are the planet's controlled vents, allowing molten rock, gases, and heat to escape from the deep interior, preventing the buildup of excessive pressure. Most volcanic activity occurs quietly at mid-ocean ridges, beneath miles of water, or in slow, effusive flows in places like Hawaii. They are not random acts of destruction, but integral components of the tectonic system, providing a necessary outlet for Earth's internal energy, like a slow, steady sigh from deep within, ensuring the planet's equilibrium and releasing stress in a regulated, long-term manner. The profound realization that Earth is constantly changing brings a meditative perspective to our place in geological time. When we consider the slow, patient dance of the continents, the gradual rise and fall of mountains, and the endless recycling of crust, our human lifespan becomes a mere blink in the planet's vast story. This perspective can be incredibly grounding, reminding us that permanence is an illusion on a geological scale, and that change is the only constant. It invites a tranquil contemplation of deep time, allowing us to step back from the hurried pace of daily life and appreciate the grand, unhurried processes that have shaped and continue to shape the world beneath our feet. It's a quiet meditation on impermanence and the enduring, gentle flow of Earth's deep history. The theory of plate tectonics unified geology in the 1960s, offering a coherent and comforting explanation for many phenomena. Before this revolutionary theory gained widespread acceptance, many geological observations seemed disparate and puzzling. Earthquakes occurred in strange patterns, mountains rose in inexplicable places, and the distribution of fossils across oceans was a mystery. Plate tectonics provided the elegant, overarching framework that tied all these pieces together. It explained why volcanoes formed where they did, how mountain ranges rose, and why continents looked like they once fit together. This unification brought a profound sense of order and understanding to our planet's dynamics, replacing confusion with a calming, systematic explanation for Earth's deep, powerful, yet remarkably gentle processes. Transform faults like the San Andreas move with a creeping motion for much of their length, quietly releasing stress. While Hollywood often portrays the San Andreas Fault as a locus of sudden, catastrophic earthquakes, much of its immense length experiences a phenomenon known as aseismic creep. Here, the two sides of the fault slide past each other gradually, continuously, and almost imperceptibly, releasing tectonic stress in a slow, steady manner rather than in sudden, violent jolts. This creeping motion is a testament to the Earth's ability to slowly dissipate energy, preventing the buildup of massive stress that would otherwise lead to larger, more frequent seismic events. It's a quiet, comforting example of how the planet manages its internal forces, gently, day by day, year by year, in a long, patient geological ballet. The average plate velocity is about 5 to 10 centimeters per year, a pace so slow it inspires tranquility. To put this into perspective, 10 centimeters is roughly the length of a small smartphone or a typical human hand. Imagine an entire continent moving at this incredibly leisurely speed. It's a pace that defies immediate human perception, a silent, unhurried journey across the globe. This profound slowness means that geological change, while constant, is never rushed. It allows for a sense of deep time, where continents spend millions of years subtly shifting positions, forming and breaking apart with an almost meditative grace. This steady, barely discernible movement underscores the patient, deliberate nature of Earth's internal processes, inviting a sense of calm reflection on the planet's gentle, continuous evolution. Oceanic trenches, the deepest parts of the ocean, are formed by the slow, graceful descent of one plate beneath another. These profound chasms in the ocean floor, like the Mariana Trench, are not random gashes, but systematic features created at subduction zones. Here, an oceanic plate, cool and dense, begins its stately, unhurried plunge back into the Earth's mantle, pulling the seafloor down with it to create these immense depressions. It's a testament to the sheer scale and patience of plate tectonics, a slow, continuous drawing down of the crust that creates the deepest environments on our planet. These serene, dark depths hold immense pressure and unique life forms, a tranquil reminder of the quiet, continuous forces that sculpt Earth's most extreme underwater landscapes with an enduring, majestic grace. The formation of new ocean basins is a testament to the Earth's patient, continuous process of self-renewal. When a continent begins to slowly rift apart, often due to upwelling magma, the landmass stretches and thins. Eventually, the rift widens enough for the sea to creep in, creating a nascent ocean. It's a testament to the sheer scale and patience of plate tectonics, a slow, continuous drawing down of the crust that creates the deepest environments on our planet. These serene, dark depths hold immense pressure and unique life forms, a tranquil reminder of the quiet, continuous forces that sculpt Earth's most extreme underwater landscapes with an enduring, majestic grace. The formation of new ocean basins is a testament to the Earth's patient, continuous process of self-renewal. When a continent begins to slowly rift apart, often due to upwelling magma, the landmass stretches and thins. Eventually, the rift widens enough for the sea to creep in, creating a nascent ocean. Over millions of years,
As new oceanic crust is generated at the spreading center, this initial narrow sea slowly expands into a vast ocean basin like the Atlantic. This unhurried birth of new oceans, a process unfolding over geological ages, showcases the planet's perpetual cycle of creation and rearrangement. It's a quiet, profound act of planetary self-renewal, gently drawing new lines on the global map and sculpting vast new watery realms with steady, unwavering patience. The stability of cratons, ancient continental cores for billions of years, showcases plate tectonics' long-term structural integrity. Cratons are the oldest and most stable parts of Earth's continental crust, massive blocks of rock that have remained relatively undisturbed by tectonic activity for perhaps 2.5 billion years or even longer. They are the bedrock upon which younger geological features have formed, acting as the enduring anchors of continents. Their remarkable resilience and long-term stability demonstrate that even amidst the dynamic dance of plate tectonics, there are fundamental, incredibly robust structures that persist through eons. This deep, ancient strength provides a comforting sense of planetary endurance, proving that while the surface changes, certain foundational elements remain, offering a silent testimony to Earth's enduring structural integrity. Islands like Hawaii are formed by mantle plumes, a serene example of Earth's interior processes shaping its surface. Unlike islands formed at plate boundaries, Hawaii and its volcanic chain emerge from the middle of the Pacific Plate. They are created as the plate slowly drifts over a hotspot, a stationary plume of superheated rock rising from deep within the mantle. As the plate moves, new volcanoes form over the plume, while older ones become dormant and erode, creating a long, tranquil chain of islands and seamounts. This elegant process demonstrates the profound connection between Earth's deep interior and its surface landscapes. A slow, continuous outpouring of magma that sculpts beautiful, ephemeral islands, a gentle, creative force emerging from the planet's unhurried heart, shaping the land with quiet persistence. The steady erosion and uplift cycles, driven by tectonics, maintain the long-term beauty and diversity of Earth's landscapes. Imagine mountains slowly rising from the collision of plates, only to be gradually weathered down by wind and water, their sediments carried to the sea. These sediments then become new layers of rock, which may in turn be uplifted again millions of years later. This continuous dance between destructive erosion and constructive tectonic uplift ensures that Earth's surface is never allowed to become entirely flat or uniform. It's a slow, patient sculpting process that creates the varied terrain we see around us, from rugged peaks to rolling plains, a gentle, ongoing artistry that maintains the planet's geological vitality and stunning aesthetic diversity over vast stretches of time. The Earth's crust is constantly being recycled through plate movements, ensuring a sustainable geological system. This planetary recycling program is one of the most elegant aspects of plate tectonics. Old oceanic crust, formed at mid-ocean ridges, travels across the globe, eventually diving back into the mantle at subduction zones. There, it melts and is reincorporated into the planet's interior, only to potentially resurface as new volcanic material millions of years later. This continuous loop prevents the Earth from accumulating an ever-expanding crust or running out of new material. It's a perfectly balanced, self-sustaining system, a gentle, efficient planetary metabolism that has kept Earth geologically active and renewable for billions of years, a testament to its profound and calming equilibrium. The profound slowness of plate tectonics offers a calming antidote to the fast pace of human life. In our hurried world, where everything seems to demand instant results and rapid change, contemplating the geological clock of plate tectonics can be deeply soothing. Imagine mountains rising over millions of years, oceans opening and closing across hundreds of millions, continents drifting at the speed of a growing fingernail.
This immense patience, this unhurried unfolding of planetary history, invites us to slow down, to breathe deeply, and to appreciate the vastness of time beyond our fleeting human experience.
It's a gentle reminder that some of the most powerful and enduring changes occur with the greatest deliberation, a quiet, reassuring counterpoint to the rush of modern existence. Understanding that earthquakes are natural releases of accumulated stress can bring a sense of geological acceptance. While earthquakes can be frightening, seeing them through the lens of plate tectonics offers a more rational, even tranquil perspective. They are not random acts of planetary aggression, but rather the inevitable consequence of plates trying to move past each other, getting temporarily locked, and then suddenly slipping. This release of energy is a necessary part of the planet's continuous adjustment, like a slow-moving gear train occasionally clicking into place. It's Earth gently stretching and settling, a reminder of the immense forces beneath our feet that are constantly working to reshape the world. A powerful but ultimately natural and necessary process for maintaining planetary equilibrium. The concept of seafloor spreading, validated in the 1960s, beautifully explained the slow growth of oceans. This crucial piece of the plate tectonics puzzle revealed that new oceanic crust is continuously generated at mid-ocean ridges and then slowly moves away, like a conveyor belt, carrying the continents with it. Evidence from magnetic stripes on the seafloor, acting like a geological barcode, perfectly mirrored on either side of the ridges, confirmed this elegant process. It was a profound realization that oceans were not static basins, but dynamic, ever-growing features. This gentle, continuous expansion of the ocean floor provided the missing mechanism for Wegener's continental drift, bringing a complete, calming understanding to the majestic, slow-motion ballet of our planet's surface. The deep, quiet interior of Earth is the engine for these gentle surface changes, hidden from our daily view. Far beneath our feet, miles below the continents and oceans, lies the Earth's mantle, a vast layer of solid rock that behaves like an extremely viscous fluid over geological time. It's here that the slow convection currents, driven by internal heat, churn and swirl, providing the subtle but immense force that propels the tectonic plates. This hidden engine works with silent, unwavering power, patiently shaping the surface world without any visible effort. It's a comforting thought, this quiet, unseen powerhouse tirelessly working to maintain the planet's dynamic beauty, a constant, deep hum of geological activity that powers the gentle, continuous dance of our world. The long-term effects of plate tectonics create the stable landmasses where life can thrive for millennia. While the plates are always moving, the rate of change is so slow that continents remain coherent and largely stable over human timescales, and even for millions of years. This allows for the development of complex ecosystems, the evolution of species, and the establishment of stable environments necessary for sustained life. Without this relative stability, facilitated by the slow, predictable nature of plate movements, the constant, violent upheaval might make long-term habitation impossible. It's a profound, calming realization that the very forces that continually reshape our planet also provide the enduring foundations upon which life has flourished for billions of years, a gentle promise of geological continuity. The consistent patterns of rock types and fossil distribution across continents become perfectly clear with plate tectonics. Before the theory, scientists were puzzled by identical plant and animal fossils found on continents now separated by vast oceans, or by matching geological formations spanning across disparate landmasses. Plate tectonics provided the elegant, soothing answer: these continents were once joined. As they drifted apart, they carried with them the remnants of ancient life and shared geological histories. This revelation brought a beautiful sense of order to what was once a chaotic collection of observations, making the deep history of Earth's biogeography and geology fall into place with a calming, undeniable logic, like scattered puzzle pieces finally uniting to form a coherent, ancient picture. The slow bending and folding of rocks due to tectonic forces create intricate geological structures over vast timescales. Beneath the surface, as plates collide or slide past each other, immense pressure and heat cause layers of rock to deform. This isn't a sudden snap, but a gradual, persistent compression that can cause once flat strata to buckle into graceful folds or fracture into complex fault systems. These geological masterpieces, often revealed in mountain ranges, are the result of millions of years of patient, unyielding pressure, a testament to the plastic nature of rock when subjected to immense forces over deep time. It's a quiet, artistic process, where Earth itself becomes a sculptor, slowly molding its internal substance into patterns of breathtaking complexity and beauty. The very existence of continents is a result of the steady, differential movement of Earth's plates. Continents are essentially lighter, thicker pieces of crust that have accumulated and grown over billions of years, too buoyant to be easily subducted back into the mantle. Their formation and endurance are direct consequences of the ongoing processes of plate tectonics. Volcanic activity at subduction zones adds new material, and collisions of smaller land masses create larger ones. This gentle, persistent accumulation and aggregation, driven by plate movements, ensures that our planet has these stable, enduring land areas separate from the vast ocean basins. It's a fundamental and calming truth that the very ground beneath our feet, the land we call home, is a creation of Earth's continuous, unhurried tectonic dance. The oceanic crust is relatively young, constantly being renewed every 200 million years, a continuous cycle. Unlike continental crust, which can be billions of years old, no part of the ocean floor is older than about 200 million years. This is because oceanic crust is continuously being created at mid-ocean ridges and then, after its long journey across the ocean basins, gently recycled back into the mantle at subduction zones. This constant, slow turnover means the oceanic crust is perpetually fresh, a testament to Earth's efficient and sustainable geological cycle. It's a quiet, rhythmic pulse of renewal that keeps our ocean floors dynamic and young, a calming reminder of the planet's ceaseless ability to regenerate and maintain its surface. The Earth's atmosphere and oceans have been profoundly shaped by tectonic activity over billions of years, maintaining habitability. Volcanoes, fueled by plate tectonics, release gases like water vapor, carbon dioxide, and nitrogen, which gradually built up Earth's early atmosphere and contributed to the formation of oceans. The slow movement of continents influences ocean currents, weather patterns, and the distribution of ice, playing a crucial role in regulating global climate over vast timescales. This intricate dance between surface geology and planetary systems has ensured a stable, life-sustaining environment for eons. It's a comforting thought, this deep, ancient partnership between the tectonic plates and the very air and water we rely on, a gentle, unseen hand guiding Earth's long journey towards habitability. The slow, methodical process of mountain building, or orogenesis, exemplifies Earth's patient sculpting. Whether it's the gentle folding of sedimentary layers or the colossal collision of continental plates, mountains do not erupt into being overnight. Instead, they are the culmination of millions of years of persistent, unhurried pressure, uplift, and erosion. Imagine the Alps or the Rockies, each peak a testament to an unimaginable span of geological time, slowly pushed skyward by forces that move at the pace of a growing plant. This patient, gradual construction is a profound display of Earth's enduring power, not as sudden force, but as continuous, methodical artistry, creating the grandest features of our landscape with a quiet, persistent determination. The gradual uplift of regions like Scandinavia after the last ice age is a gentle, ongoing tectonic adjustment. During the last glacial maximum, immense sheets of ice, miles thick, pressed down on the land masses of northern Europe and North America. Now, millennia after the ice has melted, the Earth's crust is slowly rebounding, rising upwards in a process called isostatic uplift. This isn't a sudden spring back, but a gentle, continuous heave, still ongoing today at rates of a few millimeters to a centimeter per year.
It's a beautiful, observable example of Earth's crust behaving like a viscous fluid over long periods,
slowly re-establishing equilibrium after a profound change in surface load. This quiet, patient adjustment is a testament to the planet's deep, gentle elasticity and its continuous, unhurried quest for balance. The movement of tectonic plates is a fundamental rhythm of our planet, like a very slow, deep breath. Just as our own breathing is an unconscious, continuous process vital to our existence, the steady, unhurried drift of the tectonic plates forms an essential, life-sustaining rhythm for Earth. It's the planet's heartbeat, its gentle exhalations creating new crust, its inhalations recycling the old, all happening at a pace far beyond our immediate perception. This deep internal rhythm ensures the continuous cycling of materials, the regulation of internal heat, and the constant reshaping of the surface, creating the diverse environments where life thrives. It's a calming, reassuring thought, this fundamental, silent pulse that defines our living planet, always moving, always renewing itself with a profound and timeless grace. The steady flow of heat from Earth's interior drives these vast, unhurried continental motions. Deep beneath the surface, residual heat from the planet's formation, combined with heat generated by the radioactive decay of elements, creates immense thermal energy. This heat drives convection currents within the semi-fluid mantle, where warmer, less dense material slowly rises and cooler, denser material gently sinks. It is this continuous, silent flow of heat, like a slow-motion boiling, that provides the ultimate energy source for plate tectonics. Without this constant internal warmth, the plates would cease their dance, and Earth would become a geologically static world. It's a comforting thought, this deep internal warmth patiently fueling the serene, continuous reshape of our planetary home. The long-term stability of Earth's climate is intricately linked to the slow, steady redistribution of continents by tectonics. As continents drift across the globe, they alter ocean currents, influence atmospheric circulation patterns, and change the distribution of land masses at different latitudes. These changes, occurring over millions of years, profoundly impact global climate, sometimes leading to ice ages, sometimes to warmer periods. However, the slowness of these tectonic changes allows Earth's climate system to adjust gradually, preventing rapid, catastrophic shifts that life might not be able to adapt to. It's a powerful yet unhurried regulator of planetary temperatures, a gentle, long-term influence that has fostered a generally stable climate envelope, allowing life to persist and evolve across vast geological ages. The study of paleomagnetism in the 1950s provided compelling, calming evidence for continental drift. Paleomagnetism involves studying the ancient magnetic fields locked into rocks as they cool from molten magma. Scientists discovered that rocks of different ages on the ocean floor showed alternating bands of normal and reversed magnetic polarity, symmetrically arranged on either side of mid-ocean ridges. This beautiful, striped pattern was irrefutable proof of seafloor spreading and, by extension, continental drift. It was like finding a clear, undisturbed record of Earth's movements, a quiet, undeniable testament written in stone, finally confirming Wegener's bold ideas and bringing a profound sense of scientific peace to the understanding of Earth's dynamic surface. The creation of rift valleys, like the East African Rift, is a slow, majestic process of continental separation. Imagine a continent slowly, patiently being pulled apart, stretched thin by immense forces from below. This stretching creates deep, elongated depressions, where the land gradually sinks between parallel faults, forming vast rift valleys. The East African Rift, a stunning example, is a region where the African continent is slowly but surely splitting apart, a process that, over tens of millions of years, will eventually lead to the formation of a new ocean basin. It's a powerful yet unhurried illustration of continental breakup in action, a quiet, ongoing birth of new geological features, a testament to Earth's ceaseless, patient transformation. Plate tectonics teaches us patience as geological change unfolds over timescales incomprehensible to humans.
When we think of mountains rising or oceans forming, our minds struggle to grasp the sheer duration of these events. Millions, tens of millions, hundreds of millions of years. These are not just large numbers, but entire epochs where countless generations of life have come and gone. The lesson from plate tectonics is one of profound, unwavering patience, a reminder that the grandest transformations occur without haste, often imperceptibly, yet with an unstoppable, quiet momentum. It offers a calming perspective on our own temporary existence, connecting us to a much larger, slower, and ultimately more enduring story of planetary evolution. The consistent average rate of plate movement, about 3 to 5 centimeters per year, suggests a predictable underlying order. While there can be variations, the general speed at which tectonic plates glide across the Earth's surface remains remarkably consistent over long periods. This isn't a chaotic, unpredictable rush, but a steady, measured pace, hinting at the deep, stable physics governing our planet's interior. This predictable slowness instills a sense of quiet confidence in Earth's fundamental processes, suggesting an inherent order and a well-regulated system. It's a comforting thought, this planet gently ticking along at its own ancient, unhurried rhythm, a reliable engine of geological change that maintains its steady pace across billions of years. The formation of sedimentary basins, slowly accumulating layers of rock over millions of years, is a calm depositional process. Imagine vast depressions on the Earth's surface, whether on continents or beneath the oceans, where sediments gradually settle and build up. Over immense stretches of time, these layers, composed of eroded rock, organic matter, and shells, gently compress and solidify into sedimentary rock. This isn't a rapid event, but a slow, continuous process, each layer whispering a story of ancient environments and climates. Tectonic forces often create these basins, providing the space for accumulation and then slowly preserve them. It's a tranquil geological archive, patiently recording Earth's history in successive, silent strata, a calming testament to the planet's vast, quiet memory. The theory of plate tectonics provides a holistic and comforting view of Earth's dynamic systems. Rather than seeing volcanoes, earthquakes, ocean trenches, and mountain ranges as isolated phenomena, plate tectonics weaves them into a single, interconnected, and elegant narrative. It shows how every geological feature is a part of a larger, grand design, driven by the planet's internal heat and the slow dance of its rigid outer shell. This unified understanding removes much of the mystery and apparent chaos, replacing it with a sense of profound order and purpose. It's a deeply reassuring framework that allows us to appreciate Earth as a beautifully self-regulating, dynamic, and ultimately coherent system, operating with an ancient, unhurried wisdom. The Earth's lithosphere, its rigid outer layer, comprises roughly 15 major plates, each on its gentle journey. These colossal segments of rock, encompassing both continental and oceanic crust, along with the uppermost part of the mantle, are the pieces of Earth's grand, ever-shifting puzzle. Each plate moves independently, some sliding past each other, others colliding, and still others pulling apart, all with an unhurried, continuous motion. This relatively small number of major plates simplifies our understanding of global tectonics, allowing us to visualize the planet's surface as a majestic, slow-motion dance of these enormous serene entities. It's a comforting simplicity amidst the immense scale, a quiet order to the dynamic surface of our world. The deep convection currents within the mantle provide the steady, patient force for plate movement. Imagine a slow, internal ocean of semi-molten rock churning deep beneath the Earth's surface. Warm, less dense material slowly rises from near the core, spreads out beneath the lithospheric plates, and then gradually cools and sinks back down.
This continuous circular motion, like a vast slow-motion engine, is the primary driver of plate tectonics. It's a process of profound patience and immense power, constantly and gently pushing and pulling the surface plates, ensuring their ceaseless, unhurried journey across the globe. The Earth's lithosphere, its rigid outer layer, comprises roughly 15 major plates, each on its gentle journey. These colossal segments of rock, encompassing both continental and oceanic crust, along with the uppermost part of the mantle, are the pieces of Earth's grand, ever-shifting puzzle. Each plate moves independently, some sliding past each other, others colliding, and still others pulling apart, all with an unhurried, continuous motion. This relatively small number of major plates simplifies our understanding of global tectonics, allowing us to visualize the planet's surface as a majestic, slow-motion dance of these enormous, serene entities. It's a comforting simplicity amidst the immense scale, a quiet order to the dynamic surface of our world. The deep convection currents within the mantle provide the steady, patient force for plate movement. Imagine a slow, internal ocean of semi-molten rock churning deep beneath the Earth's surface. Warm, less dense material slowly rises from near the core, spreads out beneath the lithospheric plates, and then gradually cools and sinks back down. This continuous circular motion, like a vast slow-motion engine, is the primary driver of plate tectonics. It's a process of profound patience and immense power, constantly and gently pushing and pulling the surface plates, ensuring their ceaseless, unhurried journey across the globe.
This quiet, persistent energy source, hidden deep within, is the very heartbeat of our dynamic planet, a constant, soothing force. The slow process of continental accretion, where smaller land masses join larger ones, builds continents over eons. Imagine microcontinents, volcanic island arcs, or small crustal fragments drifting across an ancient ocean, eventually colliding with and becoming welded onto the edge of a larger continent. This gradual, often gentle process of sticking these pieces together adds new material to existing landmasses, allowing continents to grow in size and complexity over hundreds of millions of years. It's a quiet, patient form of planetary construction, assembling the intricate jigsaw puzzle of our continents piece by unhurried piece, a testament to the long, slow, and continuous growth that has shaped the land we inhabit today, a calming process of planetary assembly. The Earth's continents are continuously being reconfigured, ensuring no static, unchanging landscape. From the formation and breakup of supercontinents to the slow rise of mountain ranges and the opening of new ocean basins, the surface of our planet is in a state of perpetual, albeit unhurried, transformation. There is no ultimate fixed configuration. Instead, the land masses are always on a journey, gently shifting, colliding, and separating, painting and repainting the face of Earth over astronomical timescales. This constant, quiet reconfiguration means that the planet is always renewing itself, always presenting new landscapes and environments, a comforting assurance that stasis is never the true nature of our world, but rather a dynamic, patient, and eternal flow of change. This profound, unhurried dance of continents finds some of its most compelling evidence in the serene discovery of geomagnetic reversals recorded in seafloor rocks, which provided irrefutable, calming proof of spreading. Imagine the Earth's magnetic field, a powerful but invisible force, flipping its polarity every few 100,000 years, a slow, majestic event in the planetary consciousness. As new oceanic crust slowly wells up at mid-ocean ridges and spreads outwards, it acts like a natural tape recorder, solidifying and locking in the direction of the magnetic field at that very moment. These ancient magnetic signatures, preserved in the rocks, form symmetrical stripes on either side of the ridge, a mirror image of polarity reversals stretching back through geological time. This perfectly patterned record, visible across vast expanses of the ocean floor, wasn't just evidence. It was a beautiful, consistent confirmation of the slow, persistent process of seafloor spreading.
revealing Earth's deep history with a quiet, undeniable clarity, a truly calming testament to geological truth. Indeed, the entire ocean floor is a vast, quiet testament to the slow, persistent work of plate tectonics. Beneath the restless surface waves, far from the hurried rhythms of human life, lies a sprawling, silent realm where colossal geological forces unfold over unimaginable timescales. From the majestic, submerged mountain ranges of the mid-ocean ridges, where new crust is gently born, to the profound, inky depths of abyssal plains and the yawning chasms of deep-sea trenches, every feature of this hidden landscape is meticulously sculpted by the ceaseless, unhurried motion of tectonic plates. It is a world of immense pressure and eternal darkness. Yet it is also a place of profound geological serenity, where the patient hand of Earth slowly but surely redraws its own face, a testament to processes so vast and enduring that they inspire a deep sense of peaceful contemplation. Contrast this oceanic canvas with the average thickness of continental crust, which is about 35 kilometers, a robust, stable foundation for the land we inhabit. Unlike the relatively thin, young, and ever-recycling oceanic crust, the continental crust is considerably thicker and significantly older, a resilient layer that has endured for billions of years in some places.
Imagine this massive, deeply rooted foundation, providing a steady and enduring platform for mountain ranges to rise, rivers to carve their paths, and life to flourish across vast plains. This immense thickness grants continents a remarkable buoyancy, allowing them to float higher on the Earth's mantle compared to their oceanic counterparts. It's this deep-seated stability that provides a reassuring permanence to our landscapes, a solid, unwavering ground beneath our feet, crafted over eons into a foundation of tranquil endurance. Further down, the subduction of oceanic plates can contribute to the creation of quiet, deep-sea trenches, fostering unique life in their immense depths. As one oceanic plate slowly and gracefully dives beneath another or beneath a continental plate, it sculpts the deepest parts of our oceans into elongated, profound depressions. These trenches, like the Mariana Trench or the Peru-Chile Trench, are not violent gashes, but rather serene, dark valleys stretching for thousands of kilometers, where the slow, persistent bending and sinking of crust creates immense pressure. In these extreme environments, far removed from the sunlit surface, specialized forms of life have evolved, thriving in the cold, dark, and nutrient-rich waters. It's a remarkable testament to Earth's gentle creativity, where a slow geological process creates isolated ecosystems, fostering a unique, calm biodiversity in the deepest, most tranquil parts of our planet, a hidden world of quiet wonder. And from those deep submerged realms, we witness the slow, methodical uplift of ancient marine sediments to form mountain ranges, which speaks to geological persistence on a grand scale. Picture vast layers of sand, silt, and ancient shell fragments accumulated over millions of years on the quiet ocean floor, perhaps home to countless serene marine creatures in a forgotten past. As tectonic plates collide, these once soft sediments are caught in the immense squeeze, slowly compressed, folded, and thrust upwards, a quiet transformation of seabed into sky. Over tens of millions of years, these marine origins are forgotten as they are elevated higher and higher, forming the majestic peaks of mountain ranges like the Himalayas or the Alps. It's a process of profound patience, where the gentle accumulation of tiny particles eventually gives rise to the most monumental features on Earth, a testament to the unhurried yet unstoppable power of the planet. This illustrates the comforting truth that the Earth's surface is not a fixed entity, but a gently flowing, ever-changing mosaic of plates. Imagine our planet as a colossal, slow-motion artwork, where the continents and ocean floors are not rigidly locked in place, but are instead dynamic pieces, constantly yet imperceptibly shifting and interacting. This mosaic is never static. Rather, its components glide and collide, diverge and converge, driven by forces deep within the Earth.
The beauty lies in its unhurried pace, so slow that we perceive mountains and valleys as eternal, yet knowing they are part of an immense, ongoing resculpting. It's a peaceful understanding that the world is alive, continually renewing itself, preventing stagnation and offering a sense of dynamic tranquility, a constantly evolving masterpiece. A key mechanism in this grand design is the concept of slab pull, which describes the gentle gravitational force that helps oceanic plates sink into the mantle. Picture a cold, dense segment of oceanic crust having journeyed for millions of years from a spreading ridge, now arriving at a subduction zone. Because it has cooled over time, it is denser than the warmer mantle beneath it. Gravity, with its quiet, omnipresent force, then begins to exert a gentle downward tug, pulling this heavy slab of crust deeper into the Earth's interior. It's not a violent descent, but a slow, continuous sinking, like a heavy curtain gently falling. This slab pull is one of the most significant drivers of plate motion, a natural, elegant mechanism where the Earth recycles its own surface, a process of quiet, inherent balance that sustains the planetary engine. This constant renewal of Earth's surface by plate tectonics prevents it from becoming a lifeless, cratered world, much like our Moon or Mars.
Without the ceaseless activity of tectonic plates, Earth's crust would be a rigid, unbroken shell, accumulating impact craters from meteoroids over billions of years, much like our celestial neighbors. But instead, our planet's surface is perpetually churned, melted, recycled, and resurfaced. Volcanic activity fills in depressions, erosion carves new valleys, and the slow movement of plates literally wipes clean large portions of the geological record. This continuous, unhurried revitalization ensures a dynamic and ever-changing environment, maintaining a vibrant landscape, active water cycles, and a stable climate over geological time. All essential conditions for the rich tapestry of life we see around us, a continuous, quiet planetary rejuvenation that allows life to thrive. Embracing this perspective, the deep time offered by plate tectonics can be profoundly relaxing, putting human timescales into a comforting context. When we contemplate processes that unfold over millions, even billions of years, the slow creep of continents, the patient growth of mountains, the gentle opening of ocean basins, our own fleeting lives and daily worries seem to recede into their proper, smaller scale. It's a reminder of the Earth's immense, enduring patience, a testament to forces that operate far beyond our human urgency. This vast temporal canvas invites us to slow down, to breathe deeply, and to appreciate the unhurried rhythms of a planet that has existed and evolved for so long, and will continue to do so long after we are gone. It's a peaceful reflection on impermanence and the deep, silent continuity of the natural world. From this deep time perspective, we can appreciate the slow, almost imperceptible growth of mid-oceanic islands over millions of years as a truly serene phenomenon. Imagine a singular, persistent plume of magma, known as a hotspot, rising from deep within the Earth's mantle, gently breaching the oceanic crust. As the tectonic plate slowly glides over this stationary hotspot, a succession of volcanic eruptions occurs, each one quietly adding new layers of lava to the seafloor. Over vast stretches of time, these incremental additions build up, layer by patient layer, eventually breaking the ocean surface to form new islands. This unhurried process, as exemplified by the Hawaiian island chain, creates a graceful linear progression of landmasses, each island a quiet monument to the enduring power of a deep internal heat source, a beautiful and slow-motion creative act of our planet. Indeed, the Earth's core, though deep and incredibly hot, fuels the gentle dance of the plates above it with an understated power. Far beneath our feet, an immense metallic sphere, hotter than the surface of the sun, steadily generates heat through the decay of radioactive elements and residual heat from the planet's formation. This internal warmth is not chaotic, but rather the quiet engine that drives the stately movements of the mantle, setting up vast, slow convection currents. These currents, in turn, exert a gentle, persistent tug and push on the overlying tectonic plates, guiding their majestic, unhurried journey across the globe. It's a profound and continuous energetic exchange, a hidden internal furnace that orchestrates the serene surface ballet, ensuring the planet remains dynamically alive without ever rushing. This internal ballet also manifests in the gradual closure of ancient ocean basins, a tectonic ballet that leads to new continental collisions. Imagine a vast ocean spanning millions of square kilometers, slowly beginning to shrink as oceanic plates subduct beneath converging continents. Over tens of millions of years, the seafloor is steadily consumed, and the continents on either side inch closer and closer. This isn't a sudden crash, but an incredibly long, drawn-out embrace, culminating in the gentle, immense coming together of landmasses. As the ocean basin finally disappears, the two continental blocks, buoyant and unyielding, slowly crumple and fold against each other, giving birth to towering mountain ranges. It's a grand, unhurried performance spanning geological ages, a testament to Earth's patient forces reshaping its surface through immense, quiet collisions. What's truly reassuring is the relative scarcity of major catastrophic events compared to the constant slow motion, which highlights Earth's overall stability.
While the news often focuses on dramatic earthquakes, volcanic eruptions, or tsunamis, these events, though devastating, are infrequent punctuation marks in a geological story largely defined by quiet, steady processes. The vast majority of tectonic movement, the millimeters per year drift of continents, the gentle upwelling at mid-ocean ridges, the slow descent of oceanic slabs, occurs without any noticeable human impact. The Earth's internal engine hums along with remarkable consistency, maintaining a profound balance over immense timescales. This underlying stability, far more prevalent than rapid, destructive change, offers a deep sense of calm, reminding us of the planet's inherent resilience and patient endurance. Thinking of this planet-wide calm, the Earth's crust is truly like a gigantic slow-motion jigsaw puzzle, constantly reassembling itself. Imagine an incredibly intricate puzzle with dozens of massive pieces, the tectonic plates, each drifting independently, yet always interacting with its neighbors. Over millions of years, these pieces slowly separate, creating new gaps filled by rising magma, or they gently collide, pushing and folding each other into majestic mountain ranges. They may slide past one another with a grinding embrace, or one might slowly dive beneath another, disappearing into the mantle to be recycled. This colossal, unhurried game is perpetually in play, never truly finished, but always in a state of quiet, deliberate transformation, a continuous, calm rearrangement of land and sea on a planetary scale. The beautiful alignment of mountain ranges and deep-sea trenches across the globe is a direct result of these precise plate interactions, an elegant, organized outcome. When you look at a global map, you can almost trace the boundaries of these slow-moving jigsaw pieces by observing the great geological features that delineate them. The towering, majestic Andes, for instance, perfectly parallel the deep Peru-Chile Trench in the Pacific, a clear signature of the Nazca Plate slowly subducting beneath the South American Plate. Similarly, the dramatic Japanese archipelago and its associated deep trenches mark another zone of intense but patient interaction. These geological formations are not random. They are the deliberate, sculpted patterns etched onto Earth's surface by the quiet, persistent forces of collision, subduction, and spreading, forming a global tapestry of immense beauty and order. Adding to this sense of order is the ridge push mechanism, where gravity gently pushes plates away from spreading centers, aiding their motion. Picture the mid-ocean ridges as broad, elevated swells on the ocean floor, where new, hot, buoyant oceanic crust is continuously being formed. Because this newly formed crust is warmer and less dense, it sits at a slightly higher elevation than the older, cooler, and denser crust further away from the ridge.
Gravity then quietly acts on this slight topographic difference, causing the entire lithospheric plate to slowly, almost imperceptibly, slide downhill away from the elevated ridge. It's a subtle but continuous force, a gentle gravitational nudge that contributes significantly to the overall movement of the tectonic plates, a quiet, pervasive engine for global change. These gentle nudges and pulls are ultimately driven by the deep, quiet mantle convection cells, which slowly but surely circulate material, driving tectonics from below. Imagine colossal, sluggish currents of semi-molten rock swirling beneath the Earth's rigid outer layers, vast circular pathways of material taking tens of millions of years to complete a single loop. Hotter, more buoyant material from near the core slowly rises, cools as it approaches the surface, then gently sinks back down into the depths, like an immense, silent convection oven. These immense, slow-motion movements create frictional drag on the overlying tectonic plates, gently but persistently pushing and pushing them across the planet's surface. It's a silent, powerful, and utterly patient engine, a deep internal churning that ensures the surface plates remain in continuous, unhurried motion, a constant, soothing force. This deep rhythm gives rise to the grand concept of a supercycle, where continents repeatedly assemble and disperse, a grand, slow cosmic rhythm. Imagine Earth's continents not as fixed land masses, but as participants in an ancient, recurring dance, gathering together over hundreds of millions of years to form colossal supercontinents like Pangaea or Rodinia, only to slowly fracture and drift apart once more, scattering across the globe. This cycle of assembly and dispersal then begins anew, unfolding over 500 million years or more for each iteration. It's a profound, overarching pulse of the planet, a slow, majestic breathing in and out of continental configuration, a cosmic rhythm that speaks to the enduring, patient processes of Earth, ensuring continuous change and renewal on the grandest possible scale. And it is this grand, slow cosmic rhythm that allows the long-term geological record, undisturbed by rapid changes, to reveal Earth's serene past. Because plate tectonics operates at such an unhurried pace, the geological processes leave behind a remarkably well-preserved history in the rocks. Layers of sediment accumulate over millions of years, fossils are gently encased, and volcanic flows solidify, each marking a moment in deep time. These undisturbed strata, like the pages of an ancient, colossal book, can be calmly read by geologists, allowing us to reconstruct ancient environments, trace the journeys of continents, and understand the planet's quiet, continuous evolution. It's a testament to the Earth's patience, offering a clear, consistent narrative of its deep past, free from sudden, chaotic discontinuities, providing a calming sense of continuity. Indeed, the Earth's continents are like slow-motion boats calmly sailing across the planet's surface, a truly peaceful image. Picture these colossal landmasses, laden with mountains, forests, and civilizations, drifting majestically and silently upon the more fluid mantle beneath. Their journey is measured not in knots, but in centimeters per year, an imperceptible glide across the vast blue oceans of our planet. They chart their courses over millions of years, sometimes converging in gentle, immense collisions, sometimes separating to allow new seas to form between them. This beautiful metaphor captures the essence of continental drift, a serene, unhurried journey on a scale beyond human comprehension, yet so fundamental to the ever-changing face of our world, a quiet, eternal voyage. Beneath these slow-motion boats, the deep, ancient crust of continental shields provides stable foundations for life for billions of years. These are the cratons, the oldest and most resilient parts of the continental lithosphere, often found at the core of continents. Formed in Earth's early history, they have since remained largely tectonically stable, resisting significant deformation or melting through countless cycles of mountain building and continental breakup.
Imagine these immense, deeply rooted blocks of rock acting as anchors of stability, providing platforms upon which younger geological formations accumulate and life can flourish undisturbed for vast expanses of time. They represent immense geological patience, offering a profound sense of foundational permanence, a quiet, unyielding bedrock that has supported ecosystems for billions of years. And sometimes, alongside this deep stability, the gentle subsidence of land due to tectonic downwarping can create serene coastal plains over time. While collisions uplift, other tectonic forces can cause regions of the crust to slowly and gradually sink. Imagine a broad, shallow basin quietly forming, perhaps near a continental margin, as the crust slowly flexes downwards under immense geological stresses or changes in mantle dynamics. Over millions of years, this gentle sinking allows marine sediments to accumulate and the sea to gradually encroach, creating vast, flat, and often incredibly fertile coastal plains. These tranquil landscapes, perfect for agriculture and rich in biodiversity, are a testament to the quiet, subtle processes of landform creation, where the patient hand of tectonics slowly lowers the land, inviting new environments to emerge. This patient, consistent rhythm ties back to the uniformitarian principle. The present is the key to the past, which finds its ultimate expression in plate tectonics.
This profound and comforting idea suggests that the slow, gradual geological processes we observe operating today, the erosion by wind and water, the accumulation of sediments, the gentle movement of plates, have been at work largely unchanged throughout Earth's vast history. There's no need to invoke sudden, catastrophic events to explain the planet's evolution. Rather, the immense scale of time allows these gentle, persistent forces to sculpt our world. Plate tectonics provides a comprehensive framework for this principle, showing how mountains rise and fall, oceans open and close, and continents drift, all through the continuous, unhurried operation of familiar geological laws, offering a deeply reassuring continuity between past and present. This continuity is sustained by the slow, sustained energy release from Earth's interior, maintaining the tectonic engine without abrupt shutdowns. The planet's internal heat, primarily generated by the radioactive decay of elements deep within the mantle and core, provides a continuous, incredibly long-lived power source for plate tectonics. Unlike a mechanical engine that might sputter or cease, Earth's geothermal engine is a reliable, self-sustaining system, slowly but steadily releasing energy over billions of years. This constant, gentle flow of heat drives the mantle convection currents, which in turn move the tectonic plates. It's an assurance of profound stability, a quiet, unwavering heartbeat that keeps the planetary processes alive and evolving, ensuring the Earth remains a dynamic, living world for eons to come. A beautiful byproduct of this enduring process is the formation of natural mineral resources over vast geological time, a calm offering of plate tectonics. Many of the precious metals, fossil fuels, and unique gem formations we value are not random occurrences, but are slowly concentrated, heated, and transformed deep within the Earth's crust over millions of years, thanks to tectonic activity. As plates collide, subduct, and spread, they create the necessary conditions of intense pressure, heat, and fluid movement that facilitate the formation and deposition of these resources. It's a testament to the Earth's patient alchemy, where slow geological processes quietly gather and refine elements, offering up treasures from its depths in its own unhurried time, a generous and steady endowment from the planet itself. This steady transformation explains the relatively young age of the ocean floor, generally less than 200 million years, which reflects continuous renewal. Unlike the ancient continental crust, which can be billions of years old, the oceanic crust is perpetually being created and destroyed. Imagine a vast, silent conveyor belt operating across the ocean basins. New crust is continuously generated at mid-ocean ridges, gently spreading outwards, only to be slowly consumed and recycled back into the mantle at subduction zones. This constant process ensures that the ocean floor is always relatively young in geological terms, never accumulating the immense age of the continents. It's a quiet, ongoing testament to Earth's efficient recycling system, a perpetual rebirth beneath the waves, keeping the seafloor fresh and dynamic, a continuous, serene planetary spring cleaning. And through this ceaseless recycling, the Earth's surface is constantly being smoothed and refreshed by the patient work of tectonic processes. While erosion works to wear down mountains and impacts might leave temporary scars, the underlying tectonic engine is always at work, renewing and reshaping. New crust is formed, old crust is recycled, and sediments are deposited, creating fresh layers and new landscapes. It's a continuous, unhurried artistry, preventing the planet from becoming a geologically stagnant, featureless sphere. Instead, our world is a vibrant, ever-changing canvas, constantly being painted over with new mountains, new valleys, and new ocean floors, a quiet testament to the Earth's endless capacity for regeneration and beauty, never allowing itself to become scarred or old. While the dramatic moments of this process can be unsettling, the consistent pattern of earthquake activity along plate boundaries allows for a predictable understanding of seismic zones, bringing a form of calm through knowledge. Earthquakes, though powerful, are not random occurrences scattered across the globe.
Instead, they predominantly cluster along the well-defined edges of tectonic plates, where the slow, immense forces of plate interaction build up stress that is eventually released. This consistent, predictable distribution means we can map and study these seismic zones, understanding where and why earthquakes occur. While we cannot precisely predict the timing of individual tremors, the overall pattern provides a profound sense of geological order, allowing us to comprehend Earth's internal stresses not as chaotic, but as part of a grand, ongoing system, a reassuring framework for understanding our dynamic planet. Adjacent to these seismic zones, the steady accumulation of sediments in ocean trenches before subduction is a calm, ongoing geological process. Picture the slow, silent rain of organic matter and eroded rock particles falling from the surface waters, settling gently into the immense depths of deep-sea trenches. Over millions of years, these fine particles accumulate, layer upon patient layer, forming vast, thick deposits of mud, sand, and ancient biological remains. These sediments are quietly awaiting their eventual fate, to be slowly scraped off the subducting plate and accreted onto the overriding plate, or to be gently carried down into the Earth's mantle. It is a continuous, unhurried geological archive, quietly collecting material before its transformation, a testament to the planet's profound patience and ceaseless recycling. Ultimately, the theory of plate tectonics offers a complete, elegant, and ultimately comforting explanation for Earth's dynamics. Before this grand theory, geological phenomena like volcanoes, earthquakes, mountain ranges, and the distribution of continents seemed like disparate, unrelated mysteries. Plate tectonics beautifully and coherently weaves all these complex processes into a single, unified narrative, revealing the underlying order and interconnectedness of our planet's workings. This intellectual satisfaction, the profound understanding that everything makes sense within this elegant framework, brings a deep sense of calm and clarity. It transforms a seemingly chaotic world into a system of predictable, patient, and logical processes, offering a comforting scientific peace of mind, a complete and harmonious view of Earth's grand design. This grand design even extends to how the deep ocean currents are indirectly influenced by the slow opening and closing of ocean basins over eons. As continents drift and collide, they subtly but profoundly reshape the geometry of ocean basins, redirecting vast currents that flow through the world's seas. For example, the opening of the Drake Passage between South America and Antarctica allowed the powerful Antarctic circumpolar current to form, profoundly altering global climate. These immense, slow geological shifts gradually reconfigure the pathways and intensity of ocean currents, which in turn influence heat distribution around the planet over immense timescales. It's a demonstration of the deep, subtle interconnectedness of Earth's systems, a slow, gentle dance between the solid Earth and its fluid oceans, shaping climate with unhurried precision. This immense journey means the Earth's continents are always in motion, but with a reassuring steadiness that defines geological time. It's not a hurried rush or a chaotic scramble, but a deliberate, constant journey, each landmass gliding at its own particular yet unwavering pace, typically a few centimeters per year. This predictable, unchanging speed, far removed from the fleeting urgency of human experience, is profoundly calming. It speaks to a fundamental geological order, a planetary rhythm that has persisted for billions of years and will continue for billions more. This steadfastness imbues the concept of continental drift with a sense of immense patience and reliability, a reassuring testament to the Earth's profound and unhurried enduring nature. The presence of ancient mountain belts now worn down to gentle hills speaks to the long-term, calming cycle of erosion and uplift. Consider the Appalachian Mountains in eastern North America, for example. Once towering, rugged peaks rivaling the modern Himalayas, they have been patiently sculpted and softened by hundreds of millions of years of wind, water, and ice. Yet their very existence as gentle, rounded hills still attest to immense tectonic forces that originally uplifted them. This transformation from jagged giants to tranquil, rolling landscapes highlights Earth's quiet, continuous process of creation and repose. It's a beautiful cycle where the dynamic forces of uplift are patiently balanced by the gentle, persistent work of erosion, leaving behind a legacy of enduring serenity, a quiet testament to the planet's artistic touch. Beneath such softened landscapes, the slow, almost imperceptible transformation of rocks under intense pressure and heat within subduction zones is a silent marvel. As an oceanic plate dives deep into the mantle, the rocks it carries are subjected to conditions far beyond our comprehension, immense pressures and rising temperatures. Yet they don't simply melt away. Instead, they quietly undergo a metamorphosis, their original minerals recrystallizing into new forms, creating entirely different types of rocks like blue schist or eclogite. This is a silent alchemy, a patient internal restructuring that takes place over millions of years, deep within the Earth's hidden depths. It's a testament to the planet's continuous, quiet process of transformation, where solid rock is gently yet profoundly reshaped into something entirely new, a slow-motion magic show happening beneath our feet. The consistency of this transformation is reflected in the consistent rate of plate motion for individual plates, which provides a sense of underlying geological order. Each of Earth's major tectonic plates moves at its own steady speed, typically ranging from less than a centimeter to about 10 centimeters per year. This rate, once measured, tends to remain remarkably constant over long geological periods. It's not a chaotic, unpredictable motion, but a predictable, unhurried glide, each plate charting its course with unwavering precision. This underlying consistency and intrinsic rhythm to the planet's surface offers a profound sense of natural law and order, a quiet assurance that even on the grandest scales, Earth operates with a calming, reliable regularity, a steady hand guiding its immense processes. And so, the Earth's landforms, though seemingly static, are actually part of an incredibly slow, graceful dance. The mountains we gaze upon, the valleys we traverse, the coastlines we cherish, they are not fixed, immutable features. Instead, they are transient expressions of an immense, ongoing choreography, a ballet performed by the continents and oceans over millions of years. This dance unfolds with an unhurried elegance, a majestic flow of geological forms, slowly rising, eroding, shifting, and transforming. It's a dynamic artistry, a continuous reshaping of the planetary stage, where nothing is ever truly permanent, but everything is part of an enduring, tranquil movement. This awareness adds a layer of serene depth to our appreciation of the landscapes around us, understanding them as moments in an eternal, graceful motion. This graceful dance is orchestrated by the quiet, deep-seated forces driving plate tectonics, which operate with immense power but at a languid pace. Imagine the titanic energy contained within Earth's mantle, sufficient to move entire continents, yet its expression is one of profound patience. The convection currents churn slowly, the plates glide imperceptibly, and mountain ranges rise over eons, not centuries. This incredible balance of immense power coupled with an unhurried rhythm is deeply reassuring. It suggests a planet that is not rushed or chaotic, but rather one that operates with an enduring, tranquil strength, a testament to its inherent stability and the majestic scale of its internal engine, moving without haste or agitation. One particularly serene manifestation of this deep power is the formation of quiet, isolated island chains through hotspot volcanoism, showcasing Earth's gentle creativity. Far from the chaotic edges of plate boundaries, some islands emerge from the deep ocean as if by magic, forming long, graceful lines across the seafloor. The Hawaiian Islands are a perfect example. A stationary plume of superheated rock, known as a hotspot, rises from deep within the mantle, creating a persistent source of magma. As the Pacific plate slowly drifts over this hotspot, a continuous series of volcanic eruptions gradually builds up new islands, one after another, forming a chain. This is a silent alchemy, a patient internal restructuring that takes place over millions of years, deep within the Earth's hidden depths.
This unhurried, sequential creation of land, far from any major plate interaction, is a quiet testament to Earth's sustained internal creativity, a gentle and beautiful birthing of new worlds. This process is fueled by the deep, rhythmic pulse of mantle plumes contributing to volcanism, a continuous internal process that sustains these calm creations. Imagine a slow, colossal heartbeat within the Earth, where columns of abnormally hot rock gently rise from the deepest parts of the mantle, like plumes of smoke in a vast, subterranean chamber. These mantle plumes are a consistent and long-lived source of heat and magma, often far removed from the boundaries of tectonic plates. As they slowly ascend, they can melt through the overlying lithosphere, giving rise to persistent volcanic activity on the surface, creating features like the Hawaiian chain or the Yellowstone caldera. This deep, rhythmic pulse is a constant, quiet wellspring of geological energy, ensuring a steady, gentle creation of new land over vast stretches of time. This constant creation helps explain the relative youth of ocean basins compared to continental masses, highlighting the continuous, serene renewal of the seafloor. While ancient continental land masses contain rocks billions of years old, the oldest oceanic crust is generally less than 200 million years old. This stark difference isn't a sign of instability, but rather a beautiful testament to Earth's efficient, patient recycling system. New oceanic crust is steadily generated at mid-ocean ridges, gently spreading outwards like a geological conveyor belt. Eventually, it is consumed at subduction zones, descending back into the mantle to be remelted and reborn. This continuous process ensures a perpetually fresh, renewed surface beneath the waves, a quiet and orderly planetary cycle of creation and consumption, a constant, serene rebirth for our oceans. This grand scale of plate tectonics offers a perspective that diminishes everyday worries, focusing instead on Earth's deep time. When we consider the immense forces at play, continents drifting for millions of years, mountains rising over eons, oceans appearing and disappearing, our personal anxieties and daily stresses seem to shrink in significance. It's a gentle invitation to step back from the immediate and embrace the vast, unhurried rhythms of the planet. This shift in perspective can be profoundly calming, allowing us to find peace in the knowledge that we are part of something far larger and more enduring than ourselves, grounding us in the deep, patient flow of Earth's geological journey, offering a sense of quiet humility and wonder. Indeed, the Earth's crust is never truly static, but its movements are so slow they evoke a sense of profound peace. The idea of a moving Earth might initially seem unsettling, yet when we grasp that these movements are typically measured in mere millimeters per year, it becomes a testament to immense, unhurried stability. Our human lifespan is far too brief to perceive this subtle dance. To us, the ground beneath our feet feels utterly solid and unwavering. This incredibly languid pace transforms what could be perceived as chaos into a deep, enduring serenity. It's a movement that, on a human scale, is stillness itself, a quiet testament to the planet's vast patience, ensuring continuity and transformation without haste or disruption, a calming, profound constancy. The slow, predictable nature of continental drift has, in turn, allowed life to adapt and evolve over vast geological periods, a truly patient partnership. As continents gently shifted, they created new environments, altered ocean currents, and separated populations, slowly but surely shaping the course of evolution. This unhurried pace provided ample time for species to quietly respond to changing conditions, to diversify, and to spread into newly formed niches. It wasn't a frantic scramble for survival, but a grand, unhurried process of adaptation and change, unfolding over hundreds of millions of years. This slow, steady geological rhythm has thus fostered the incredible biodiversity we see today, a testament to Earth's patient provision of an ever-evolving canvas for life to flourish. This patient planetary shaping also gives rise to the formation of vast, tranquil oceanic plateaus by extended volcanic activity, a silent spectacle beneath the waves.
Immense outpourings of lava from deep within the Earth, not at a spreading ridge, but across a broad undersea area, gently accumulating over millions of years. These colossal, flat-topped submarine mountains, like the Ontong Java Plateau in the Pacific, cover hundreds of thousands of square kilometers. They are the result of prolonged, gentle volcanic activity, quietly building up immense, stable underwater landscapes. Unseen and undisturbed by human activity, these tranquil plateaus represent a majestic, slow-motion creation, a testament to the Earth's enduring capacity to sculpt its hidden depths with immense, unhurried power, creating vast, serene underwater realms. And thanks to the insights provided by plate tectonics, the Earth's deep past, with its shifting continents and ancient seas, can be reconstructed with remarkable clarity. Like reading a vast, ancient, and beautifully illustrated book, geologists can trace the journeys of continents across the globe, piece together the opening and closing of ancient ocean basins, and identify the locations of long-vanished mountain ranges. The evidence, from magnetic stripes on the seafloor to matching fossil records across continents, allows us to quietly map Earth's serene autobiography, understanding how the planet has transformed over billions of years. This ability to glimpse into such profound antiquity brings a deep sense of understanding and connection to our planet's patient, enduring story, a comforting narrative of deep history. This enduring story also involves the continuous, subtle changes in land elevations due to isostasy, linked intimately to plate tectonics. Imagine the Earth's rigid crust gently floating on the more viscous mantle beneath, much like an iceberg floats on water. As weight is added, like the growth of immense ice sheets during an ice age, or removed, like the erosion of towering mountain ranges, the crust quietly and slowly bobs up or down to maintain equilibrium. This gentle, persistent rebalancing act, called isostasy, ensures that the crust adjusts to changes in its load over thousands to millions of years. It's a quiet, gravitational negotiation, a continuous, almost imperceptible adjustment of land elevations, a patient dance between the solid Earth and its internal fluids, ensuring a subtle, ongoing planetary stability. At the very heart of this stability are the deep-seated convection currents, the true heart of plate tectonics, maintaining a steady, powerful rhythm. These immense, slow-motion flows of semi-molten rock within the Earth's mantle are the planet's internal engine, perpetually circulating heat and material. Hotter, less dense material gently rises, spreads beneath the crust, and then slowly cools and sinks, completing cycles that span millions of years. This quiet, continuous churning provides the fundamental driving force for the tectonic plates, guiding their movements with unwavering consistency. It's a deep, rhythmic pulse, a powerful but unhurried heartbeat that ensures the Earth remains a dynamic, living world, a continuous source of its profound, patient dynamism. A calm and enduring outcome of these plate movements is the long-term climate stability, enabling diverse ecosystems to flourish. While short-term climate patterns can be volatile, the slow tectonic dance of continents plays a crucial role in regulating Earth's climate over geological timescales. The opening and closing of ocean basins redirect ocean currents, influencing global heat distribution. Volcanic activity, linked to plate tectonics, releases gases that contribute to atmospheric composition, and the weathering of rocks acts as a long-term carbon sink. These patient, interconnected processes provide a fundamental, underlying stability to Earth's climate, creating the vast range of environments that allow for the incredible diversity of life we see today, a calm outcome that has fostered ecosystems over eons. This stability is also underpinned by the steady recycling of elements through the Earth's interior and surface, a sustainable, quiet process that ensures the planet's enduring vitality. Essential elements like carbon, water, and various minerals are not lost, but are continuously cycled between the Earth's crust, mantle, oceans, and atmosphere, driven by tectonic forces. Carbon, for instance, is sequestered in rocks through subduction and later released through volcanic activity.
Water circulates through hydrothermal vents and is locked in minerals, slowly returning to the surface over vast periods. This planet-sized, self-regulating system ensures that vital resources are continuously transformed, renewed, and made available for life. A quiet, sustainable ballet of planetary chemistry, ensuring the Earth's continuous generosity. Ultimately, the Earth's surface, constantly being renewed and reshaped, offers a profound metaphor for continuous change and rebirth, a truly relaxing thought. Every mountain rising slowly from a collision, every ocean basin quietly opening as plates diverge, every ancient slab of crust gently diving back into the mantle, these are not endings but parts of an eternal cycle. The planet is never truly static. It is always in motion, always transforming, always presenting a fresh face. This constant, unhurried renewal reminds us that change is inherent to existence, and within that change lies the promise of rebirth and new beginnings. It's a comforting image of a planet that is endlessly creative, perpetually evolving, never truly ending, but always transforming. A quiet testament to the enduring cycles of life itself. And it is through the slow, persistent pressure from these very plate movements that even the hardest, most unyielding rocks are gently but inexorably shaped and reshaped over unfathomable millennia. A process so gradual it escapes our perception, yet so powerful it sculpts continents. Imagine, if you will, the deepest foundations of our world, not as static, unchanging blocks, but as a vast, malleable canvas, responding to an unseen hand that works with infinite patience. This isn't the dramatic, sudden violence of an earthquake, though those are moments of release within this larger dance. Instead, it is a pervasive, omnipresent force, like a sculptor's hand applying a pressure so infinitesimally slow that a human lifetime would not register the slightest alteration. Yet over millions of years, it can bend, fold, and uplift entire mountain ranges from the flat plains of ancient seabeds. Consider the grand sweeping arches of folded rock strata visible in ancient mountain ranges, layers that were once flat and horizontal laid down as sediment in an ancient ocean. These layers, once soft muds and sands, became hard rock, only to be caught in the slow vice of converging tectonic plates. The pressure, delivered over millions upon millions of years, didn't shatter them instantly. Instead, it folded them, much like one might gently bend a deck of cards, creating vast anticlines and synclines, graceful curves that tell a story of immense, unhurried compression. Each millimeter of movement builds upon the last, accumulating to kilometers of displacement, transforming rigid stone into flowing, undulating landscapes. This quiet, persistent pressure is a testament to the fact that even the most solid things in our world are not immune to change, given enough time and consistent application of force. It's a reassuring thought, isn't it, that nothing is truly fixed, that resilience comes not from absolute rigidity, but from the ability to yield and adapt over time. The very concept of rock as an unmoving, eternal substance is gently challenged by plate tectonics, revealing the deeper truth. Rock, given eons, is a fluid medium. We see this in the process of metamorphism, where existing rocks are buried deep within the Earth's crust, subjected to immense pressures and temperatures. Under these conditions, the minerals within the rock recrystallize, changing their structure and composition without fully melting. A humble limestone, under the patient squeeze of continental collision, can transform into a lustrous marble, its constituent grains realigned and interlocking, creating a new, harder, more beautiful stone. A shale, rich in clay, can become slate, perfect for roofing, its minerals compressed into parallel layers, allowing it to split cleanly.
These transformations are not instantaneous. They require the relentless, crushing weight of overlying rock and the gentle warmth of geothermal heat, sustained for periods that dwarf human history. It's a natural alchemy performed at a planetary scale, driven by the quiet push and pull of the plates. This slow, deep sculpting also manifests in the creation of faults, where the Earth's crust cracks and shifts. While some faults can unleash sudden, powerful earthquakes, the underlying process of stress accumulation and gradual movement along these fractures is a continuous, slow dance. Think of the San Andreas Fault in California, a famous boundary where the Pacific Plate slides past the North American Plate. While it's known for its seismic activity, much of the movement along this fault zone is a slow, creeping motion, where blocks of crust are continuously, imperceptibly grinding past each other, accumulating stress over decades or centuries before a sudden slip. But even in these sudden slips, the preparation for the event, the buildup of strain within the rocks, is a long, drawn-out process of deformation. The rock itself bends and stretches, storing energy like a giant spring until it reaches its breaking point. This gentle bending, this patient accumulation of energy, is the quiet work of plate tectonics, constantly shaping the crust, preparing it for the next subtle adjustment. The beauty lies in understanding that these dramatic events are merely punctuation marks in a much longer, calmer sentence of planetary reshaping. It's like watching a tree grow. You don't perceive the growth, but over years, a mighty trunk emerges. The Earth, too, grows and changes, silently, persistently. The sheer scale of this patience is what truly offers a calming perspective. We live in a world that often demands instant gratification, but the Earth operates on a geological timescale that laughs at such notions. A mountain range might take tens of millions of years to fully form, from the first subtle buckling of the crust to its majestic snow-capped peaks. During this time, countless generations of life come and go, entire species evolve and disappear, climates shift dramatically, yet the plates continue their slow, unyielding march. The rocks are folded, faulted, uplifted, and then, with equal patience, eroded by wind and water, only for their sediments to be laid down elsewhere, perhaps to become part of a new mountain range in another epoch. This endless cycle of creation and destruction, driven by a quiet, persistent pressure, suggests a profound resilience, a planet that is never finished, always in the process of becoming. It fosters a sense of peace to consider that even the hardest stone, seemingly immutable, is subject to the Earth's patient will, slowly yielding, transforming, and evolving along all other forms of existence. This enduring, gentle shaping reminds us that within great pressure, over immense spans of time, beauty and transformation are not only possible, but inevitable, a quiet confidence in the enduring nature of our dynamic home. This deep understanding of how quiet, persistent pressure slowly shapes our world leads us to another profoundly reassuring realization. The consistent geological features found globally, elegantly explained by plate tectonics, bring a profound sense of order to Earth's otherwise bewildering complexity. Imagine looking at a map of the world, seeing the vast oceans, the continents, the towering mountain ranges, the deep ocean trenches. Without a unifying theory, it might seem like a chaotic jumble, a collection of disconnected features. But plate tectonics provides a master key, a grand explanatory framework that brings coherence to this apparent disarray, revealing a beautiful underlying harmony. It's like finding the hidden pattern in a complex tapestry, suddenly seeing how all the individual threads contribute to a magnificent interconnected design. This global consistency is one of the most intellectually satisfying and truly calming aspects of understanding our planet. Consider the distribution of mountain ranges. From the majestic Himalayas stretching across Asia to the rugged Andes running down the spine of South America and the ancient Appalachians in North America, these colossal landforms are not randomly scattered. Plate tectonics explains them as the colossal crumpling and uplifting of the Earth's crust where two continental plates collide.
The Himalayas, for instance, are the direct result of the Indian plate continuously pushing northward into the Eurasian plate, a collision that began tens of millions of years ago and continues to this day, lifting Mount Everest higher by a few millimeters each year. The Andes are formed by the Nazca Plate oceanic crust subducting beneath the South American continental plate, causing volcanic activity and uplifting the western margin of the continent. Seeing this consistent pattern, understanding that these diverse mountain chains are all born from the same fundamental process of plate interaction brings a wonderful sense of clarity. It's not chaos, but a grand, repeating theme played out across the globe. Similarly, the deep ocean trenches, like the Mariana Trench in the Pacific, the deepest known point on Earth, are not just random depressions. They are consistent markers of subduction zones, places where one tectonic plate is diving beneath another, recycling old oceanic crust back into the Earth's mantle. And corresponding to these trenches are chains of volcanoes, often forming arcs like the infamous Ring of Fire that encircles the Pacific Ocean. This ring, a zone of intense seismic and volcanic activity, once seemed like a fearsome, unpredictable belt of destruction. But plate tectonics shows us that it's a perfectly logical consequence of multiple oceanic plates subducting around the Pacific Basin. This consistent pairing of trenches and volcanic arcs, found repeatedly across the globe, is a testament to the elegant predictability of the tectonic system. It's like discovering that every key has a corresponding lock, every cause a consistent effect, bringing a sense of order to something that might otherwise seem terrifyingly arbitrarily. Even the mid-ocean ridges, the colossal underwater mountain ranges that snake for tens of thousands of kilometers across the floors of all our major oceans, are consistent features explained by plate tectonics. These are the spreading centers where new oceanic crust is continuously generated as molten material rises from the mantle, pushing the plates apart. The Mid-Atlantic Ridge, for example, is a vast undersea mountain chain where the North American and Eurasian plates and the South American and African plates are slowly pulling apart. The consistency of these ridges, their characteristic rift valleys along their crests, and the symmetrical magnetic stripes in the seafloor rock on either side, evidence of Earth's magnetic field reversals captured in newly formed crust, all tell a coherent story of seafloor spreading. It's a global conveyor belt operating with silent precision, consistently creating new crust and pushing older crust away, maintaining a planetary balance. This discovery, more than any other, transformed geology from a collection of local observations into a unified global science. This global consistency extends even to the fossil record and ancient climates. Before plate tectonics, it was a puzzle why identical fossils of ancient plants and animals were found on continents now separated by vast oceans, or why evidence of ancient glaciers existed in what are now tropical regions. The theory of continental drift, a precursor to plate tectonics, and then plate tectonics itself, provided the elegant solution. Continents were once joined in supercontinents like Pangaea, allowing species to migrate freely across landmasses that are now widely separated. As these continents drifted, they moved through different climatic zones, explaining the tropical fossils in polar regions or glacial scarring in equatorial lands. This ability to explain seemingly disparate observations with a single, coherent theory is profoundly satisfying. It transforms isolated pieces of evidence into parts of a grand, unfolding narrative, bringing a sense of completeness and understanding. The Earth's story, once fragmented, is now a seamless, interconnected epic. The order that plate tectonics brings to Earth's complexity is not just academic, it's deeply calming because it shows us a planet that operates on logical, understandable principles. It's a self-regulating system, vast and dynamic, yet beautifully consistent in its processes. This consistency offers a sense of stability, a knowledge that there are fundamental rules governing our world, even amidst its ever-changing surface. This discovery, more than any other, transformed geology from a collection of local observations into a unified global science. This global consistency extends even to the fossil record and ancient climates. Before plate tectonics, it was a puzzle why identical fossils of ancient plants and animals were found on continents now separated by vast oceans, or why evidence of ancient glaciers existed in what are now tropical regions. The theory of continental drift, a precursor to plate tectonics, and then plate tectonics itself, provided the elegant solution. Continents were once joined in supercontinents like Pangaea, allowing species to migrate freely across landmasses that are now widely separated. As these continents drifted, they moved through different climatic zones, explaining the tropical fossils in polar regions or glacial scarring in equatorial lands. This ability to explain seemingly disparate observations with a single, coherent theory is profoundly satisfying. It transforms isolated pieces of evidence into parts of a grand, unfolding narrative, bringing a sense of completeness and understanding. The Earth's story, once fragmented, is now a seamless, interconnected epic. The order that plate tectonics brings to Earth's complexity is not just academic, it's deeply calming because it shows us a planet that operates on logical, understandable principles. It's a self-regulating system, vast and dynamic, yet beautifully consistent in its processes. This consistency offers a sense of stability, a knowledge that there are fundamental rules governing our world, even amidst its ever-changing surface.
It reminds us that even grand, seemingly chaotic natural phenomena have an underlying logic, a predictable rhythm over vast timescales. It allows us to view Earth not as a random collection of landforms and events, but as a living, breathing, interconnected system, where every mountain, every ocean, every earthquake, every volcano is a part of a larger, ordered dance. This deep sense of planetary coherence, this consistent global architecture, explained by an elegant, unifying theory, truly helps to quiet the mind, offering a gentle reassurance that even in the face of immense power and constant transformation, there is an overarching order, a steady hand guiding the Earth's geological destiny. And as we gently absorb the calm order that plate tectonics brings to our world, our minds are naturally led to contemplate the final, perhaps most profoundly relaxing, aspect of this grand geological story: the vastness of geological time, revealed so clearly by plate tectonics, which offers a humbling and deeply relaxing perspective on our place in the universe. Imagine a clock that ticks not in seconds, minutes, or hours, but in millions and billions of years. A clock that has been faithfully marking time since the very birth of our planet. Plate tectonics is the mechanism that allows us to read this clock, to decipher the deep history etched into the Earth's rocks and landscapes. It tells us that the mountains we see today are but fleeting expressions of crustal uplift, destined to erode away over eons. It shows us continents drifting across the globe at speeds comparable to the growth of a fingernail, but doing so for hundreds of millions of years, closing ancient oceans and opening new ones. This immense timescale, often referred to as deep time, is almost incomprehensible to the human mind. Yet meditating on it can bring an extraordinary sense of peace and perspective. Our lives, measured in decades, feel incredibly significant to us, and rightly so. Yet when placed against the backdrop of geological time, our existence becomes a mere flicker, a brief moment in an ongoing, vast drama. This isn't meant to diminish our lives, but rather to expand our understanding of what it means to be a part of something truly monumental. Consider the journey of a single continent, say North America. Over hundreds of millions of years, it has moved from a position near the South Pole, across the equator, and into its current Northern Hemisphere location. During this epic voyage, it has been part of several supercontinents, collided with other land masses, rifted apart, and experienced countless cycles of mountain building and erosion. Each mountain range that defines its landscape today, the Appalachians, the Rockies, represents an event that unfolded over tens of millions of years, a blink in geological time that took longer than the entire existence of humanity. The very ground beneath our feet, solid and unchanging in our perception, is merely on a very, very long journey. This vastness of time teaches us patience and humility. It reminds us that our immediate concerns, while important in our human sphere, are part of a much larger, slower dance. The urgency we often feel in our daily lives can begin to recede when we consider that the Earth has been patiently unfolding its story for 4.5 billion years, navigating colossal changes with an unhurried grace. Mountains rise and fall, oceans appear and disappear, species evolve and go extinct, and the planet simply continues its quiet, persistent work. There is no rush, no panic in the Earth's geological processes. It simply is, and it transforms. This perspective can be profoundly relaxing, allowing us to let go of the need for instant results and embrace the beauty of gradual, enduring change. It's like watching a slow-motion film of the entire planet's history, where every frame represents millions of years, and suddenly the furious pace of human life seems to slow down, allowing for a deeper breath. The idea of deep time also offers a powerful antidote to our anxieties about permanence. We build cities, create works of art, establish cultures, all striving for something lasting. Yet geological time shows us that nothing on the surface of the Earth is truly permanent.
The mighty Himalayas, which seem to scrape the sky eternally, are already eroding, their peaks slowly but surely being worn down by wind, ice, and water, their material carried to the oceans to form new sediments that will one day become new rock, perhaps to be uplifted into a new mountain range millions of years from now. This cycle of creation and destruction, driven by tectonic forces over vast timescales, is not a cause for despair, but a testament to the Earth's continuous renewal. It's a calming assurance that even as things end, new things begin, in an endless, graceful ballet of planetary transformation. Our individual contributions, our brief lives, are woven into this tapestry of deep time, a part of something far grander and more enduring than we can fully grasp. To truly feel the relaxation this perspective offers, close your eyes and imagine a single grain of sand, born from a mountain, carried by a river, deposited in a delta, cemented into sandstone, buried deep, metamorphosed into quartzite, uplifted again only to be eroded once more. This single grain's journey, stretching over hundreds of millions of years, is a microcosm of the Earth's patient evolution. It's a journey filled with unimaginable events: the rise and fall of dinosaurs, the formation of ice ages, the slow drift of continents. And yet the grain persists, changing form but never truly disappearing from the Earth system.
This is the soothing rhythm of deep time, a reminder that we are all part of an ongoing, interconnected story that began long before us and will continue long after. It invites us to release our grip on the immediate and embrace the infinite, finding a quiet sense of belonging within the vast, unhurried flow of planetary existence. Plate tectonics, in its revelation of geological time, offers a profound sense of cosmic tranquility. It shows us a planet that is not static, not finished, but constantly evolving, continuously creating and recreating itself with immense patience and power. It reminds us that the Earth is a dynamic, living entity whose processes are so grand, so ancient, and so unhurried that they offer a peaceful counterpoint to the often frantic pace of human life. From the quiet shaping of rocks to the consistent order of global features to the humbling vastness of deep time, plate tectonics provides a framework for understanding our world that is both intellectually stimulating and deeply wonderfully calming. It is a story of enduring change, of interconnectedness, and of an ancient planet that continues its steady, silent work, offering us a profound sense of peace and a gentle reminder of our place within its grand, eternal dance. If these quiet facts about our planet bring you a sense of calm and wonder, allowing your mind to drift peacefully, then please consider subscribing to the channel. There are so many more calming facts and soothing scientific journeys waiting to help you relax and fall asleep.